Hello and welcome to Math with Mrs. Becker. Today we are looking at calculus, focusing on ideas pertaining to the derivative. So this is Chapter 1, Section 3, our second day of looking at these concepts. Here are some examples. Find the equation. So remember, one of the tricky things is a lot of times what they're asking for is going to differ from question to question. Sometimes, like this one, they want an equation. That means that your final answer needs to be y equals mx plus b, some equation in that form. If they want you to find the point, that means it's an x and a y. Okay, you need the ordered pair. If they want the slope, that would mean that your final answer, all you need is the slope of whatever the situation is. So it's very important at this level of math to make sure that you read the question so you know exactly what it is you're trying to find. Okay, back to this. Find the equation to the tangent line to the graph f of x equals the square root of x at point 1, 1. Well, in order to find the equation of a line, of any line, whether it be a parallel line, a perpendicular line, a tangent line, in order to find the equation of a line, you need a slope and you need a point. Well, we have a point, but we don't have a slope. That's where the derivative comes in. My f of x, because what we know right now is we know the power rule, how to find the derivative. So I don't want to leave this as a square root of x. I'm going to go ahead and change it into x to the 1/2 power, because now I can use the derivative rule that we know. To find the derivative, you bring the 1/2 out front, you keep the x the same. Now I go ahead and I take the original exponent minus 1. 1/2 minus 1 is negative 1/2. Now I can't leave it like this because you can never have a negative exponent in your final answer. So it's 1 over 2 to the x, 1 over 2 times x to the 1/2. It went on the bottom, that's how the negative went away. However, x to the 1/2 power, we know that's really a square root of x. I can't have a square root on the bottom, and I couldn't leave it like this because this means a square root. Okay, so if you're looking and saying, well, Becker, you didn't have to write it as a square root, then we could have left it. No, you couldn't, because this has the same value as this. You can't have a radical on the bottom, whether you write it in fraction form or as a radical, okay? So make sure that if you have a fraction exponent on the bottom, you do realize it's a radical and we have to rationalize. So I'm going to go ahead and multiply top and bottom by the square root of x. So square root of x over 2 times the square root of x times the square root of x is the square root of x squared, which is x. This is the derivative. Okay, now that's not your slope. The derivative is the formula to find the slope based off of x. Our ordered pair, the x is a 1. So I take the derivative and I have to change the x's to a 1. So it's the square root of 1 over 2 times 1. Well, the square root of 1 is 1. 2 times 1 is 2. So this is the slope. Now I have a slope and I have a point. So I can go ahead and find the equation of a line. It's y minus the y from the ordered pair, 1, equals m, 1/2. X minus the x from the ordered pair, it's a 1. Go ahead and distribute. So y minus 1 equals 1/2 x minus 1/2. If I want to get y by itself, I need to add 1. When I add 1, I'm going to go ahead and write it as 2 over 2. This still has a value of 1, but now I have a common denominator with the other constant term, so I can combine them. So y equals 1/2 x. Your common denominator of a 2 stays. Negative 1 plus 2 is a positive 1. This is an equation. That's what the question was asking for. So the equation of the tangent line through this graph, meaning if you drew the parent function, the square root of x, if I went to the right one, up 1, and I drew a tangent line, this would be the equation of that line. So you would start up half a unit. Then to find each additional point, you'd go up 2 or up 1 over 2, up 1 over 2. Super cool. Okay, there's number 1. Let's do it again, okay? We just want to feel really confident with this whole process. Find the equation of the tangent line of the graph f of x equals x squared, where x is negative 1/2. In order to find an equation, you need a slope and a point. To find the slope, I need to take my function and find the derivative. The derivative of x squared is 2x. Now to find the slope, you take the derivative and fill in your x value. They told us our x value was a negative 1/2. So 2 times negative 1/2, positive times a negative is a negative, 1/2 of 2 is 1. So my slope is 1. I have a slope and an x. You need a slope and a point. If I want to find the y value, what you have to do is take your x value and fill it into the original function. To find y, x goes into the original function. I square everything, the negative, the top, and the bottom. Negative times a negative is going to be a positive. 1 squared is 1, 2 squared is 4. So your y value is 1/4. So my ordered pair, x is negative 1/2, y is positive 1/4. Now I have a slope and a point. I can find the equation. Y minus the y from the ordered pair equals m. X minus the x from the ordered pair. Notice I changed this to a plus because I was minusing a negative. If I distribute, y minus 1/4 equals x plus 1/2. Add the 1/4 over. Y equals x plus 1/2 plus 1/4. Now y equals x is fine. I need to make a common denominator here. So I need to change 1/2 into 2/4. My denominator is a 4. 2 plus 1 is 3. So the equation of the tangent line through my parent function, the quadratic, remember that's a parabola that's opening upwards, okay? If I go ahead and I graph that, if I go on the point, negative 1/2, positive 1/4, and I draw a tangent line, this would be the equation of the line. Okay, let's keep going. Find the equation of the tangent line to the graph of f of x equals 5. Okay, again, equation. Equation means we need to have a y equals mx plus b form of an answer. In order to find that, we need a slope and a point. Okay, if I'm going to go ahead and find the slope, this is a constant. What that means is I really have like 5x to the power of 0. So when I go ahead and I multiply that, 0 times 5 is 0, and I don't have any x's, okay? When this is a constant, your derivative is a 0. So if I go ahead and I fill in the x value, well, you can't fill anything in. There's no variables here. So no matter what your value of x is going to be on this line, m is going to be 0, because if you have y equals a constant, that is a horizontal line. And the slope of a horizontal line is 0 no matter what your x value is, because it's never going up and it's never going down. It is just staying even throughout the entire x values going left and right. Okay, so here is my slope. If I want to find my ordered pair, I know x is negative 2. Again, there's no place to fill in a negative 2. This is y equals 5. So no matter what the x is, the y value is 5. So I have a slope, I have a point. Y minus the y value from the ordered pair, which is 5, equals m. X minus the x value. So there I'm minusing a negative. That's why I changed it to a plus. When I distribute the 0, that becomes a 0 and that becomes a 0. So I have y minus 5 equals 0. I need to get y by itself, so I add 5 over, so y equals 5. If you feel better, you could say y equals 0x plus 5, just because that way it's in that y equals mx plus b format, but you do not need to. X equals 5 is sufficient. Okay, let's step it up a little bit, okay? Because the previous 3 were kind of reviewing part one, but just going a little bit further, okay? Now let's go ahead and take it another step further. The tangent to the graph of y equals 1 over x at the point P, a and 1 over a, where a is greater than 0, is perpendicular to this line. Okay, I know as you read that, you were probably like, oh my gosh, that is so much stuff. Okay, there are a lot of different things we're looking at. One thing that I know is that when you're given another line and they tell you if it's parallel or perpendicular, what that tells me is that I can identify the slope that I need based off of this line. Then you don't need that line anymore. So I'm going to go ahead and do that right away. The slope of this line is 4. I need mine perpendicular. Remember, perpendicular means opposite and reciprocal. So if the slope was 4, this is positive, that's why mine is negative. This is 4 over 1, that's why mine is 1 over 4. So I can go ahead and I can get rid of that. That information just helped me to identify the slope. Okay, they want us to find the point. So here it says the tangent to the graph of y equals 1 over x. So that's my function. My function is 1 over x. Remember in the first part of 1.3, they said if you have 1 over x, you want to rewrite it so it has an exponent, because then we can use the power rule for finding the derivative. So I'm going to go ahead and do that. I bring the negative 1 out front, keep the x, take the original exponent and minus 1. You cannot have a negative exponent in your final answer. So it's negative 1 over x squared. That's what the derivative is, okay? So far, I know what my original function was. I was able to find the derivative. The derivative is the formula for the slope. We want our slope to be perpendicular to the line that they gave us. That was a negative 1 over 4. So if I want to solve for x, which, yes, they're telling us they want to find p, which is an ordered pair, they're trying to confuse you a little by just changing the x to an a. What you want to do here is solve for x. That would be your a value because it's the x value of the ordered pair. So I take the derivative. I want to know when that derivative is equal to negative 1/4. If I end up with more than one solution, let's say I have a positive and a negative, you have to do the one that is greater than 0, okay? Well, I can go ahead and multiply both sides by a negative 1 because negative cancels a negative, negative cancels a negative. I can cross multiply this thing, guys. Check this. I have 1 over x squared and 1 over 4. I have a proportion, 2 fractions with an equal sign in between. 1 times 4 is 4. X squared times 1 is x squared. If I want to solve for x squared, I have to take the square root. Now I'm canceling a power of 2, so I need to include positive or negative. So it's plus or minus. The square root of 4 is 2. That's what x is. Okay? And x, they're calling it an a. But a has to be greater than 0. So even though it could be a positive or a negative 2, they gave me a limitation. I can only include the positive. So a is a 2. If a is a 2, then your y value is 1 over 2 because it's 1 over a. So here is your point. Your point is 2 1/2. The wording is a little bit tricky. Just go one step at a time. Obviously, we're not going to do just one of those, and I expect you to know how to do it. So guess what? We're going to do it again. The line y equals negative 1/3 x plus b is tangent to the graph y equals 1 over x at the point P, where it's a and 1 over a. Again, a is greater than 0. Find P and determine B. Okay, so this time we know that this is the tangent line, correct? I already know the slope because I have the equation of the tangent line. Y is by itself. When y is by itself, your slope is the number that's in front of x. So our slope is negative 1/3. I need to be able to find a. In order to do that, I first have to figure out the derivative of the function. The derivative is the formula of the slope, so I can take the formula equal to the slope. That will allow me to solve for x, which they are now calling a, just to confuse you. But don't let it confuse you. X is a because a is in the same location of the ordered pair is x. If I'm finding the derivative, f of x is really x to the negative first power. This is the same one that we just did last time. Bring the negative 1 out front, reduce the exponent by 1, so it's a negative 2. That is the same thing as negative 1 over x squared. That's your derivative. I know that this is the formula for the slope. I know that my slope equals negative 1/3. So I can say negative 1 over x squared equals negative 1/3. Well, I can multiply both sides by a negative. What will happen is it cancels the negatives. So 1 over x squared equals 1 over 3. Go ahead and cross multiply. 3 equals 1 times x squared is x squared. Cancel a power of 2 by taking the square root. So x is really plus or minus the square root of 3. But here's my limitation. Okay, when I'm calling it x, that's fine. Now they want us to find the point. A has to be greater than 0. So the value of x that's greater than 0 is a positive square root of 3. When I go to put that in the y value, it's 1 over a. It's the square root of 3. You cannot have a square root of 3 on the bottom. So I need to rationalize the denominator. So I end up with the square root of 3 over 3. That is p. Okay, so we want to find p. And b. Okay, so if I want to find b, I have a slope and I have an ordered pair. Y minus square root of 3 over 3 equals negative 1/3 x minus square root of 3. If I go ahead and I distribute, y minus a square root of 3 over 3 equals negative 1/3 x. Negative times a negative is a positive. When you're multiplying fractions, remember it's top times top, bottom times bottom. This ends up being the square root of 3 over 3. Now I can go ahead and add square root of 3 over 3. So y equals negative 1/3 x plus. I have a common denominator. 1 square root of 3 plus 1 square root of 3 is 2 square roots of 3. So b is 2 square roots of 3. That's about as tough as this will get for day 2. Okay, this one dealt with square roots. The wording of the problem is really, really wonky. Just take one step at a time. I guarantee you for every single question, you will have to find the derivative because that's what we're studying right now. So if you don't know where to start, step 1, find the derivative of the function and then go from there, okay? Because you know for sure 100% of the time you will need the derivative in order to accomplish what it is that they're asking for section 1.3, okay? Now that we already learned how to do a derivative, we're going to move in and find what's called a second derivative. Oh, sorry, I jumped ahead. I saw second notation. Darn it, I thought we got to do a second derivative today. Okay, a second notation, meaning just another way that you can write this, of a derivative is dy over dx. It's read the derivative with respect to x. So whatever the variable is, that's what's on the bottom. So the derivative of y, the y is f of x. Remember, it's interchangeable with y. So the derivative of y with respect to the variable x. This means the same thing as this. It's just two ways to say, hey, find the derivative. So if they have find the derivative of y with respect to x of x to the power 6, find the derivative. So it's 6x to the power 5. If they say find the derivative of y with respect to x of 1 over x, you would get negative 1 over x squared, and that's what we did in the last two examples. The derivative of y with respect to x of x cubed, it's 3x squared. So the next couple, they're just going to give you that notation so you get used to seeing it. It means find the derivative. So here they want us to find the derivative of x to the negative third power. So the negative 3 comes up front, you rewrite the x, negative 3 minus 1 more, that's a negative 4. You cannot have a negative exponent in your final answer, so x to the power 4 has to go to the bottom. Find the derivative if y equals x to the negative fourth. So I take the negative 4 out front, I rewrite the x, negative 4 becomes negative 5 because I have to minus 1. I cannot leave it like this because you cannot have a negative exponent. Negative 4 goes on the top, x to the power of 5 goes on the bottom. That is day 2 of 1.3. I just randomly picked out 16 questions that I thought would help further your knowledge of how this works and just give you some good practice. So go ahead, give them a whirl, and I'll talk to you soon.